welcome everybody. I'm Jackson Felden from the Cloud Lunch and Learn group. And today we have one more session here. I have with me Dexit ready. He's a data engineer and is ready to present automating visualization with Data Factory, SQL Server, and Power BI. I was talking to Dexit and we kind of agree between us. If you guys have any questions, please feel free, type those questions on the chat box, and then I will ask him to come up with the answers as we go, just to make a session a bit more dynamic. Yeah, that's it. If you want to do a quick intro about yourself, and then I will share your screen, and then you can take over the presentation.
Thank you. Thank you very much, Jackson. Hello, everyone. Welcome to this session on automating visualizations with Azure Data Factory. My name is Dikshit Reddy. I am a data engineer at a tech consulting company based out of Detroit, Michigan. I have been working as a data engineer for the past 2 years, specialization in SQL, and I have been dabbling myself in SQL, Python, Power BI. um, what I do is I help data scientists and data visualization analysts to get the data that they want. The future of data analytics workflows is automation. The past decade, companies spent all their resources on getting the data to their scientists and data
Yeah.
visualization analysts, and but the coming decade is going to be automation of the data pulling process, so that the decision makers do not need to depend on upstream data analysts to run SQL queries manually, or run Python manually to make data frames and give them the visualizations. Rather, all the data will be present in its pristine, clean format, so that the business decision makers can just focus on making business decisions rather than spend all their time cleaning the data and checking if the data is correct or not. So this automation
Yeah,
process
makes sense. Yeah.
is becoming more and more important as companies move towards data democratization. Data
Hmm.
democratization is making data available to every department, whatever data belongs to them, so that those departments can be data driven rather than intuition driven. And making this data driven democratization organization is only possible with the help of automation, and this automation is enabled with the help of cloud technologies, since cloud technologies have all their orchestration frameworks,
Hmm.
all the data storage, and as well as connection to the downstream tools in one place, and it makes easier to integrate all that into one point. So I would say the role of a data engineer is becoming more and more important, but learning how to automate your processes becomes even more important as you go forward in this
Yeah.
uh,
Okay.
step. So
Okay. Let me share your screen, and then you can take over. Let me just add here. One
yes,
second. Yeah, you are there. Okay, I will be here on the background if you need. I will keep my eye on the questions
oh,
if they come, and then yeah, from now on, yeah, please take over. And if you need anything from me, I will be here on the background. Okay,
thank thank you very much, Jackson.
okay, you can go ahead now. Good
Yeah,
man.
sure. So I'll be starting off with a basic of the process that we had followed. This is a case study that I'll be showing you. We had followed a basic process, and this can be applied to any analyst who spends hours every week, or a couple of hours every month cleaning data sheets or wrangling data sheets and bringing about data into spending a lot of time cleaning data sheets and bringing the data into pristine format. His or her work can be automated. So in this case study, I will start off with what the process was. So the analyst would spend around 200 hours a year extracting, cleaning, and analyzing the data. That was the old process, which is shown with the left hand side or the back side. But now we have to save time for the analyst by providing the dashboard that updates itself every month. So whatever manual data cleaning or data extraction process that happens has to be cleaned and provided, automated, so that the analyst doesn't need to even touch the data. He, she, or they can just update the data, can just double click on the Power BI app or the downstream app or visualization tool they're using, so they can just see what's happening. So this was a basic process flow. The analyst would get CSV or Excel sheets from their process owners or from the data owners, and before they would do all the analyzation and cleaning and modification themselves. But now, what they would do is they would drop these CSV sheets in a SharePoint folder. The SharePoint now, a very important part of the SharePoint folder is access. So the access is given only to the analyst, so that no other person will touch to remove the CSV sheets or to put the CSV sheets. Or at the same time, you can also share the access of your SharePoint folder to the downstream data sources, so that they know what kind of data they're putting in. And another important and advantage of SharePoint is there's version control. So we don't need to save Excel sheets or CSV sheets and V1, V2, V3, V4. Whenever we drop a sheet with the same name, that only that one will be saved with the latest version. And also we can go back and see what was the previous version and the third version before today. And in that way the version control is protected and safeguarded, while even the access control to the SharePoint folder as whole is saved. And also SharePoint folder can be linked to your Teams channel, to your Outlook, and this makes it really compatible, and henceforth we can use the SharePoint folder. Now, once the process owner or the data sourcer adds the tables in the form of CSV sheets to the SharePoint folder, it is pulled into the cloud database with the help of Azure Data Factory, and then it's pushed into the SQL Server, where all the cleaning and the transformation rules and checking for the data types, checking for null values, checking for duplicates, making sure that the merges are happening on the primary keys properly, making sure that different types of analysis is done, making sure that the updates and the inserts and the update on primary key is done properly, are updated over here. And then it's pushed in, and then that data is pulled in by a visualization tool. It could be Power BI, Tableau. I just use Power BI here. And once it's pulled in, the visualization will be, and then the downstream users can either use that data to manually build a visualization, or we can build a visualization which will be automated once this part is done. So if the process happens in this way, it's way more automatic and way more error free, since proper rules are set in the transformation stage. And also the monitoring becomes really easy, since there are proper schedulers over here in the cloud technology, as well as uh, proper processes to pull are already preempted and set up here. Whereas the downstream users will have access only to this tool, so they don't know what rules or what kind of processes is happening, and they won't have access to touch any of these processes, and these are safeguarded with the help of IAM rules. So this is the basic process. And it's pretty much straightforward. Any data engineering process follows this. There will be basic one cloud tool. All the cleaning and the extraction happens, and the connections between them will be again done with the help of cloud, like Azure Synapse or Azure Data Factory. And then the downstream business users will have access to only this. Next, we'll start moving forward. So this is the architecture overview that I would like to explain. uh, so basically, before we dive into technical skills, let's take a look at the overall architecture for implementing. There are six key components involved. That is the SharePoint folder, which I talked about. Then the blob storage. This is the blob storage. We will use Azure service to store the SharePoint folder in the blob storage for easier access to the components of Azure. The blob storage basically has all the CSV sheets. So this is blob storage is the SharePoint of Azure. From SharePoint, data is pulled into the blob storage. You can call this as a downloads folder of your laptop. Our laptops have downloads folder. Azure Data Factory has a blob storage in order to save the data. Then we have the linked service, that is basically linking. Linked service is basically like the you can call the linked service as the pipes, or as the conduits to connect one source to the other. uh, Link service can also be termed as the toll gate of in our roads. We have toll gates that allow people and do not allow people, and they help connect one road to another road through proper security checks. And this linked service is that kind of a toll gate that allows us, that checks if this is allowed to be connected to the remaining part of the architecture or not allowed to be connected to the remaining part of the architecture. And it is also a connection point. Then we'll have the logic app, which will come in between. We will use Azure service to schedule files pulls from the blob storage, which I'll be talking about next. Logic App is basically a scheduler and an orchestration tool. Then we have Azure Data Factory over here. This is a cloud-based service which is used to orchestrate the data flow between component. And then we have the SQL server where all the CSV sheets will go and be stored in form of tables in a database in a schema, and all the transformation cleaning process happens with the help of stored procedures. And then finally we have Power BI. The Power BI is connected to the SQL server after which comes after this table. Now we'll be setting up the SharePoint folder and blob storage integration. So it is pretty much straightforward. We basically have the link of the Azure blob storage, and we have the link of the SharePoint folder, and whoever has a permission of the SharePoint folder will have permission to the Azure blob storage, or the data engineer can have the permission to the Azure blob storage. You can use a tool like Azure Logic Apps or Microsoft Flow to automate the process of copying files from SharePoint to blob storage. Now, what is Logic Apps? Logic Apps is basically an a tool that will time the pulling of the data. So whenever a data folder is dropped, it'll immediately sends and it'll pull. So this pulling function is basically done by Logic Apps. In the next slide, I'll be showing in detail on how to operate a Logic Apps. But yeah, uh, first we log into our SharePoint site and navigate to the desired location. We create a new folder to create the CSV files in the SharePoint folder and name it appropriately, and then use the URL. Uh, I will go to the next slide and I will show you how we will be doing that. No, okay.
Yeah, just that's it. Can you make your slides a bit bigger? I'm not sure if you want to go full screen or just make a bit bigger. The
This is okay.
at at the bottom, I think you can reduce the comment. Yeah, there you go. Oh yeah,
Okay.
that helps. Yeah. Okay, go, my name. Thank you.
Oh, okay. Perfect. Okay. Because I can't see my screen if I do PowerPoint, if I do slideshow, it shows in both the screens when I do slideshow. That's why. Okay. The basics of creating SharePoint and Azure Blob Storage are very much straightforward. We create a folder in the SharePoint and name it appropriately and make a note of the URL. So the SharePoint will have a URL, and the Blob Storage will create a new account, which I'll be showing later on in the Azure Data Factory live demo on how to create the Blob Storage. Then we create a new container within the storage account to store the data from stored SharePoint folder. Then we make sure to give the access over here to whoever we want to. Then we integrate these both using this portal in the Azure Data Factory to automate the process, and this will ensure the data is readily available. Now that we have the SharePoint and the blob storage already linked, we'll go to the Logic Apps. This is the Logic App basically. Now in the Logic app, once you click on the Logic app in the Azure Data Factory, you will have a search bar. You search for Logic app, and if you have permissions, and you double click on the Logic app, this kind of a box setup will be opening up, where you will be linking your SharePoint folder to the Azure Blob storage with the help of the Logic app. Okay. Now, Logic app is basically the trigger that pulls the data from the SharePoint folder to the Blob storage, and we give it a meaningful name first, and then we this is the shared documents container, that is the SharePoint folder, and this is a path which we'll be giving. We'll be connecting it. We'll be using the link service connection over here, and also if we need any other details that be filled here. And then this is the blob storage. We are creating a blob storage, the storage account name. We should give a meaningful name so that people can understand. The blob content is file content, so people can even move like videos or even photos from SharePoint folder to blob. But over here we'll be using file content, CSVs. People use even parquet files, and parquet files help with like headers and stuff. We can easily deal with headers in a parquet file, but over here we'll be moving file content. And then we configure the trigger. In Logic App, there's a point where you click over here and it'll help to configure the trigger, and we search for recurrence trigger and add it to the workflow. Now the trigger is added to the interval, that is, do we have to pull every week, day, or month. And then once we do that, we set up the actions to copy file from blob from SharePoint to blob storage. And after the trigger, the actions to the workflow, we use get file properties only, get file content properties only. And for each loop, we iterate over the files. So every loop, it'll go to the SharePoint folder and it'll iterate the files. We give the HTTP request over here, and we give the URLs of the SharePoint folder as well as the blob container over here. Okay. Now that the logic app is set up, we will go to the configuring of the pipeline. Now, now this part, until this part is set up, we have to now pull the data into data factory and pull it into the SQL server or the Azure SQL database. You can use any one of them. I would recommend SQL server because uh, many people are accustomed to the SQL server in the community, as well as it's easier to store procedures and edit and do as per our UI UX ease or convenience. But even Azure SQL database is more or less the same, and you can it's very easy UI UX to do. So we create pipelines and pull data from this blob storage to the SQL database and then publish the pipeline. Now, to create a pipeline, just go to the data factory, and then there's a plus sign in the data factory. You get pipeline, and you can get the copy and the transform functions. I'll be showing that after the presentation in the demo, how to do that, and the blob storage container, these both things. Now, a very important aspect of this data pipeline is you need to put the copy data uh, icon before the store procedure task, because copy data is pulling the data and store procedure is pushing that data into the store procedure that does this part. So this copy data should be before the store procedure, and the sequence of steps should be kept this way, because the activity will execute the SQL Server store procedure for data cleaning and transformation, whereas the copy data will handle the data movement from blob to SQL Server. So we need to be careful with this. That is the one thing. And second thing is, we need to, if you want to add more parameters like updated date, current date, and any kind of date, time, insert date and stuff, we can add over here with the help of these values. That so this process will be automated. And then this is the stored procedure user properties, which you'll get here, and SQL account user properties if you have any IAM roles that you need to define.
Yeah,
Yeah.
just there is a question.
Yes.
Yeah, the question is why we need Logic App. ADF has SharePoint connector. Not sure if you can
Yes.
elaborate a bit on that.
Yes. So the SharePoint connector will not help schedule, will not help the trigger. We need Logic App or Power App flows to trigger the process. So the Logic App will basically be a trigger, so that when the file falls, there should be something to sense the falling of the file and pulling of the data. So that trigger is given by the Logic App.
Oh,
Uh,
okay, makes sense. Yeah.
SharePoint connector we can use when we do manual pulling, when we give manual commands for Synapse and Azure Data Factory, but we use Logic App for the trigger of the process. Yes.
Okay,
Then
thank you.
once, yeah. Next question.
No, that's all for now. Yeah.
Yeah. Okay.
Okay, thank you.
So then we validate and publish the pipeline, and then if everything is set up correctly, the publishing of the pipeline goes smooth. Now, a few things I would highlight here is we often make mistakes in the table names. Downstream tables are not present. Those are the things that you need to be careful of. The data types, need to be very careful what data type is being pulled and what data type is being pushed, because CSV have data type problems. Another thing is headers. Some files have headers, some files do not have headers. The headers are in the first row, in the second row. Go through all these processes once or twice. Spend a lot of time with the business to make sure that the data source comes in the format that you're putting up on the table names, or you make sure that the data or whatever format it's coming in, based on that you design the downstream data in the SQL server. There are automated processes for making sure that if you use, instead of CSV, if you use Parquet, then it becomes way more easier, because Parquet takes all the data in whatever format it is, and also it detects the data formats, as well as it makes sure that the first row comes as a header or does not come as a header, and that makes the process all easier. So these are the few uh, from an experience of a data engineer, I'm telling these things so that it makes your pipeline process easier and hassle free. Now, with the pipeline process, we can trigger it manually or schedule it using a trigger to automate the process, and it can be pushed to Power BI. Next, in my next, so after this comes the in the SQL Server, we have three layers in for moving the data. That is staging, transformation, and final layer. The data comes in its raw format in the staging. Then it is pushed to the transformation layer where we see for duplicates, nulls, data types are correct, there are no columns missing, or there are only full null columns that can be deleted, uh, and any kind of checks we want to do in terms of if there's any PII data, personal information data like the SSN number, we can mask it off so that people downstream do not get access to it. uh, we can also check that there are no only null rows, so that we can delete those only null rows in the data table. That happens in the transformation, and any kind of external transformation we need to do before merging onto the final table, uh, so that the final production table is kept clean and pristine. That all those transformations can be done in the transformation layer for cleaning and processing. Then the clean transform data comes into the final layer, and in the final layer we'll usually have like a merge or an update statement on the primary key. So those all you who are strong in the SQL game, they'll be knowing the importance of primary key and how we can use updates, merge, and insert statements based on the primary key so that there are no duplicates. So the final layer will have those kind of uh, checks and balances so that the production table is kept clean and ready. Staging and the transformation layers will usually have truncate and load, so that the truncate and load operations, and the final table will have update or merge upsert operations where you do update and insert. And the stored procedures are saved like this. Anyone with SQL knowledge will be knowing in SQL Server, and they'll be stored in this data scheme. Okay. Once this kind of transformation is done and the final table is there, we'll be connecting it to the Power BI. So Power BI is also in Power BI, we already have the get data option where we can click here and then go to the source. The source will be SQL Server database. Now all the data comes to the SQL Server and then it's connected to the Power BI. Modeling part we do in the Power BI, so that the end business user, if he wants to understand how the whole process is happening, he can just go here and then he can just go to the semantic layer and see that how the data is connected one to one to many. Now I do understand that a lot of downstream business people don't have data skills, but a lot of companies which are aiming at data democratization are teaching downstream business people these kind of skills and making them adept to Power BI. So what was 20 years ago? What how people would look at Excel sheets? Like maybe 30 years ago, knowing Excel was like a skill. Microsoft Excel was a skill that would be required at the job interviews, but now more or less everyone knows Microsoft Excel. The skill level Microsoft Excel has been democratized among organizations and companies with the advent of desktop PCs. Now, in the future, I feel that as companies become more data driven, they'll Power BI and Tableau will be basic knowledge of Power BI and Tableau. I'm not saying advanced. Basic knowledge of Power BI and Tableau will be communicated among all the analysts and business decision makers, and people will be knowing Power BI. More people will be knowing downstream to visualization tools like Tableau and Power BI, and they'll be able to understand at least a basic data connection part. If not, also for if there's a visualization analyst helping the downstream business maker, for him or her, they don't need to go into the SQL Server database to check how the data is connected. They can just go to the semantic modeling layer and see that okay, the data is connected in this format, and then they can create the visualization. So this makes the whole process easier for the visualization analyst, for the data engineer, as well as the business decision maker. We can go to the home tab, click on get data, and then connect. And then once the connection is established, we need to create a semantic layer to better the structure and the model of the data. And this is a very crucial component that allows us to interact with the data more intuitively. Mm. So what would look like 4 or 5 Excel sheets of different sizes and formats, and null values and empty values and duplicates would all be joined together, and we'll get this beautiful visualization at the end. It is very clean, pristine, and done. And then the downstream analyst can just double click on the Power BI app in the window in his desktop, in his or her desktop, and the visualization will open. He or she would spend around 10 to 20 hours a month on getting the data sheets, joining together in Excel, and cleaning them and doing VLOOKUP or those kind of things to create a visualization, or even basic column chart analysis. All that is automated and looks in this clean format, and they can, if they have basic knowledge of Power BI, or if they can take a visualization analyst help and create even more visualizations on top of this, and the whole decision making process can be accelerated and helps data driven organization to democratize data among their organizations. Now I will show basic tools, basics of yeah. So this is Azure Data Factory, and over here you copy data, and then and then you can create a stored procedure function, and then you can attach them like this. And over here you can go to the source, you click what is the data source, you can go plus here, and then you can click what you want to show, like the SQL server, or Azure Data Lake Storage, Azure Database for PostgreSQL, Azure SQL Database. That is, but over here we are using the source format, so we'll use Azure Blob Storage and click continue. And then what is the source of the file? Is it a delimited text, Excel, Parquet, XML? So we can click CSV and press OK. And over here, this is the name, and this is a link service. We can use a new link service, or what kind of link service that we need to use. You can click here. Now that's how we create uh, the source. And then the sync will be, again, you give the name of the sync. Over here you click the sync dataset, you click new, and we are pushing this into the blob storage. So we click blob storage and click continue, and then whatever CSV Parquet format we need, we can click that, and then we can click continue. We can suppose use CSV, click continue, and then name, and then the link service that we want, and then we can go ahead with that. After it goes to there, then we can create one more copy data where we pull from the blob storage to the SQL server. So over here the source was blob storage, and then over here the sync will be, we click here, and then Azure database for MySQL, or Azure database for PostgreSQL, Azure SQL database. We continue, and then we click the link service, we click new, and over here we can give the database name and the table name, and then the authentication type which we are using. For now for now I'll discard, and then we can do the mapping. We can import the schemas if we have, or we can give new schemas. And the settings, we don't need to touch this. If you want to enable logging and send an email, that you can use here, and these are the user properties. This is how you do the basics of uh, data factory, basics of data factory. And this is a blob container. So whatever files we get are stored in this format and in these files, and then this is how the blob container works. And over here we have the, if you want the URL of the blob container, we can get the URL. We can refresh it, and then we can show the URL. Yeah, we can take the container properties, and then we can get the URLs over here, the name and the URLs, which will be giving it in the storage pointers, in the storage connectors. So that's how this works. And then there is something called as a Microsoft Fabric. So uh, it's very important for us to be in touch with the latest things that are coming up in Microsoft, or any new technologies. So with the help of code being generated now, with the help of Copilot and OpenAI, Microsoft has come up with Microsoft Fabric, which is basically a connection between Power BI, Azure Synapse, and all the ADF integrations. And then if you go to this page, Microsoft Build, which is happening now May 23rd to 25th, you will be seeing this analytics Microsoft Fabric, and it's basically a connection between, it basically integrates everything into one lake. It's a software as a service foundation, and then you can pull the data and push the data from beginning to end. And if you're interested, you can learn more about this and be more and more focused on this. And yeah, that's this. What I'd shown was technology that is basically being used, and now we have more developments that are coming every day, and we need to keep ourselves abreast about these developments. And if you have any questions, I'll be happy to take. Thank you very much.
Okay, yeah, everybody watching this session, if you have any questions before we finish, feel free to type on the chat box. Otherwise, we can finish the session in a few seconds. Yeah, really interesting topic to see all the different technologies working together. And as you said, automation, the data is there. Now the next step is to create the automation around that. That's interesting.
Is this session recorded, Jackson? I just wanted to ask.
Yeah, that's right. Yeah, it's going to be available. We are streaming now online on YouTube, and then it will be available in a few minutes, I believe.
Perfect.
Yeah. Yeah, oh, okay. We haven't got any other question, and then I would say that's it for today. And thanks very much for your time with us for these last few minutes. And thanks everybody from home watching us. And follow us on LinkedIn and the other social media for the upcoming events. Okay,
Perfect.
everybody. Thanks very much, and see you next time.
Bye bye.
Thank you. Bye.